Hello everyone, today I am going to deliver a lecture on axial force, shear force and bending moment diagram of the frame. So mainly we will focus the shear force and bending moment diagram of the 2D frame. Okay, the math example of 2D frame. So before going to the start I am seeing some theory. The frame is an essential severe flexural member oriented in different direction and concentrated by rigid joint. Therefore, axial force, shear force, and bending moment diagram in different processes into drawing individual axial force diagram, shear force diagram, and bending moment. Each of the member are similar to the beam, and assigning the diagram of the entire of the frame using the free body diagram of each moment will using free body diagram and equilibrium summation of f of x equal to 0 summation of y equal to 0 summation of f of j mz equal to 0 or the each joint must be concentrated while drawing member is free bodies. Okay, so let's start. Okay, so this is our first example. Draw the SFD shear force and bending moment diagram from the given figure below. Figure is given here. So let's start. So at first I'm taking the moment at point A here. So we are taking the 5 keep load is 5 moment is given here in negative anti-clockwise, and cy into 11 cy as a cy and 11 is distance is given is 5 6 into 5 which is 11 and 2 into 2 into 6 in the ideal load, and 5 it will be 5 into 6 divided by 2 and minus 10, and we will be seeing minus 10 into 3 and found cy equal to 11.91. So these are the cy, and summation of fyi, if we take the summation of fy then it will be ay and cy we are taking 11.5 and the downward is 2 into 16, and in this way ay will find 0.09 keeping upward. So summation of f of x will be named, if we take the summation of f of x then ax will be 10 as the 10 keep is given the negative direction. Okay, so let's see this member B. This is the BA member. So if you before taking the BA member we have to take the here the theta angle. So now we will go to the theta is here, then theta is length, which is the we have been found as 6 is length, here is a 6, and this is the and this is the height not and this is the height and this is the length and 5, and found the theta is 50.91. If we, this is the theta. So let's see the assume the theta, how we'll calculate how will act is the perpendicular and this perpendicular as it is inclined. So I'm just taking here inclined. If I taking the some Snapchat, taking some sniping moment. Okay, so let's see here. This is our mechanism. I'm just here taking the perpendicular here. So we've been taking here the perpendicular is going here according to this. So what will be happening? So we know this is the theta, as we have been found this is the theta. So we have been seeing the two type of component is going through here, as one is going is here, another is going here, and this is the perpendicular or 90 degree, and this is the theta, and this is the 30 minus theta. In this way we will calculate ay into sine 39.41, which is 0.051. It is taken in the direction of perpendicular. So if we calculate here, we can see that we can see here we can see these are the going passes through here. So these are the going passes through here, and another is this frame is passes through the all are perpendicular, and we know this is the theta. So if this is the theta, then it will be also theta. So if so there is, we know the theta, the component of theta is cos theta. On the other hand, the opposite side of the theta is will be sin theta. That's why we will be using sin theta, which is 7.61. So this value will be 7.61. Okay, so 7.61 it is coming from 10 kip load, and we have been this is the coming from 10 kip load, and we have been found another is AY, which is upward. So we have been seeing this is the AY is upward. So it is taking the two type of component. I am just discussing all things. So now we will taking the AY here. So AY passing through here, and we know this this is the member. This is the member. So it will be divided in component two type. One is here and another is here. So we know this is the value of theta is given, and another was in theta is not given. So given theta is cos theta, and another theta is sin theta. So AY sin theta is 0.051. If we adding this 7.68 and 0.58, so this will be acting in total load. So this way we are just adding here 7.6 and 0.61 we have been found from here. So two type of load we have been taken considered here. So we have been seen here 7.67, 7.738, and another is we have been seeing 7.61, which is taken from 10 kip load. As we go here, the 10 kip load is acting here. So we know that theta is this theta is this theta, and this theta is this theta. So we know this component will be cos theta, and another will be reversed in the sin theta. So tan into sin theta, which is 7.68. So that's why 7.68 is acting this line. So we have been taking 10 load, but it will be acting this way, perpendicular. It is divided in component on perpendicular, as we have been seen here. It will be given in this and this type. So that's why we are taking the vertical, which is 7.67. If we deduct this value, then we will be taking the downward is 7.61 and upward is 7.738. So it will be downward also 0.58. We will be taking the moment is here, as we know 7.738 into 3.5 3.595 and 3.599, which is 7.8, and it will be plus, as we have been taking the it is negative. That's why it is taking negative sign we have been consider, and the positive sign we have been consider 7.68, and found the moment 30.47. So now we have to draw the shear force diagram. As we have been seeing, 0.57 is downward, 0.57 is downward given here. There is no loading here. After that we have been seeing 7.61 is also down here, and the total is 7.738 is down here, and there is no load at all. And we have been seeing the upward is 7.61. That's why it is upward, and diagram will be 0. As we have been seeing, the moment is we have been found the 30.47. So 30.47 at first we have been taking the upward, and there is another is we have been 0.0 it will be 0.58 into 3.67, and we have been reducing 30.48. So it will be slightly reduced like this. And 30.08 we have been seeing here the shear force 7.738, and it will be multiplied with 30.905, and it will be gone here, it will be 0. Okay, so this diagram, the BC diagram has seen that. Now we will see, let's see the diagram of BCD. So remember that this is the what I will say, this is the moment. So the moment will be carry at the point we have been seeing, the point is B. That's why the moment also will carry here. So we have been seeing here another part we have been seeing here. The moment is taking here. So this moment already taken, already gone to here for the balance purposes. As this is the joint of B, this is also joint B. So it will be taken a negative sign and anti-clockwise. That's why it is taking the clockwise moment. Okay, let's see. So we have been and another we have been found here AY. We have been seeing 0.09. AY also is taking here the balance purposes. Okay, after this finding this diagram, so we are taking we are now doing the shear force diagram. We have been seeing 11.91 is taking upward, and we have been deducting 2 into this distance. So how we will calculate distance? As usually we will calculate by this method, but we are not finding this method. That's why we are taking the shear force. We are taking at shear force here. So 11 into 11 is down upward, and downward is 2 into x. X is we know, where will be shear force in 0. There, that's why we are assuming x. Then x equal to 0. So x is the value of x will be 45.995. Okay, that's why now we will calculating here 2 into deducting here and found this value. And in the similarly, we've been seeing the 5 kip is already given here. We've been seeing here the 5 kip per feet is given here. The anti-clockwise, that's why we're considering here the negative. So we're getting negative in shear, so there is no value. So shear force is given here. So after calculating, the value is coming here as per 30.7. So we are just dragging here 30.7. 70. After that we are taking the minus 0, then it will be slightly change in downward, but we have been taking the upward, but it will be not upward, and it will be like this. Okay, let's see another example. We have to draw the shear force and bending moment here. So the equation is given here. Some moment we have been taking at point B. This is the point B, and after taking all the moment and found Fy, the Fy value is 38.25, and we have been taking summation of Fy upward is positive, so that's why we will want Fby, which is taking negative word, so that's why 11.25 is getting the negative, and summation of Bf equal to it will be 3. Okay, so let's see here. Here is the we have to taken some at first we have to taken some theta. This is the theta. How we calculate the theta? We know the distance. Here is a 3 into 3. This is the distance 3 into 5 into 5, and this is the 1 into 3 into 1 plus 3 into 3. So after founding this, now we are calculating tan theta. Tan theta we have been taking here. Tan theta 5 by 3 and found 49.3. This is the theta. So this will be theta. So now we will calculate the f point. This is the f point. This is the f point. So first diagram we are calculating f1. So we know f1 is 31. It is given f1 value is given here in upward fy. But we have to calculate the FC member. This is the FC member. So it is divided. The component is divided FC and fy. So if we calculate in this direction, is perpendicular to here, so we are taking this moment. So yes, 90 minus theta, so it will be this is related to cos theta. On the other hand, the opposite side will be sin theta. That's why we will using sin theta here, and found the value is 19.6, which is taken 19.6 here, 19.68. And another point we have been found is 30. This is the 30. 30 will be divided 2.5 with how we get. Let's see here. Consider 30. This is the 3 group load. Is the second diagram we have been seeing. The 3 group load is given here, and the member is here. So the load is divided into component. One is perpendicular here, and another is here. So theta is opposite here. That's why the sin theta will be here, and after the using 3 into sin theta, which is 2.57. So 2.57 is applied is here. We've been seeing from this diagram. Let's see. 2.57 we have been found here, and we have been seeing 19.6 and 2.57 upward. So that's why balance per percent we have been in 22.5. So after taking the moment, how we calculate moment to 19.68 into 2.915 and 19.68 and 5.318. So after total distance and 2.57 into 2.917, 2.97 and and 1 to 2.2 kg per foot. This is the moment. So now draw the shear force. Here the shear force diagram, as we've been seeing, the upward will be 19.6 foot and there is no below, it will go there, and upward is also 2.57 and 22.2, and there is another is downwards 22, so this will be 0. So we've been seeing here the 19.6 into 2.91, so it will be gone there as 50.57, and it will be positive. Will them adding this value and found 22.2. After now we're deducting here the negative balance purpose, it will be downward and it will be 0. Okay, so we have to see here the moment, the joint is here, so the joint is moment we have been found 20.22, so that's why we have been applying here 20.22 from this balance purposes. And 30.25 is Fy, we have been given 30.25 pound here, so all load is going to go here. So the diagram is looking like this for the member of A, B, C, D. So this is the point A and B, C, D. This is the member, and after taking all these forces and putting all these value, calculating the looking like this. Okay, so let's see another example. The shear force bending moment of the frame we have been seeing here. It is also here. So we are taking the moment from here. So 12 into 3. This is the diagram. We have been 3. And after all the calculation found dy, which is dy 33.49, and after the calculation summation of Fy, we will find Ay, which is 14, which is 40.54, keeping upward, and summation of Fx, there is no summation of Fx, that's why it will be 0. So at first we have been taking this theta, so I'm just taking the screenshot. I'm taking the screenshot here for your convenience. So let's see, I will calculate the theta. So this is we are calculating this theta, as we know this is the distance, it is the 8, the height is 8, this is the 3 into 3 into 6, and we will calculate this theta. I will calculate this theta. So let's see, this is the theta calculation. Theta is equal to 8, which is a vertical and distance, and the horizontal distance is 3, and found the theta is 53.3, and theta minus 90 we will be calculating 36.67, and the hypotenuse we have been calculating 8 square minus 6 square, which is 10, the distance of the A and C. Okay, let's see the how we will calculate the 8.81. Now we will calculate the, I'm just erasing here as we have been taking the all the theta. So as this is the inclined, so we have to calculate the inclined force here from 14.54. So let's see, as 14.54 we have been taking the load is going to upward 14.54, but we are taking to here this value, we need to this value. So we know this is the perpendicular, that's why it will be, it is the not theta, that's why it will be sin theta. So 14.54 into sin theta, and it will be 8.74, which is given here 8.57, and there is a 12, another load is given 12. So how will calculate, how will convert it 7.2. So let's see how we calculate 7.2. The second another diagram we've been seeing here, we've been found, we've been given that this is the theta, and if we calculate this, the load is applied here, and this theta will be this theta, and this will be another opposite theta. So this will be cos theta. So if we want to this force, so we know this will be component, we have to calculate the component. So we know this theta and this theta are same, so tan into cos theta will be 7.2. That's why we have been found 7.2. Okay, so we know the 8.74 is upward and 7.10 is downward, so we need to say 1.54 for downward for balance purposes. Now we calculating the moment is here, so after calculating 8.74 into 10, 5 into 5 into distance, and 7.2 into 5, and found the moment is positive 51.4. So now draw the moment shear force. We've been taking the positive is upward and going in, and then downward, going downward and then 0. And we've been taking the this area, so we'll go taking this here, and this will also calculate this one. It will be 50.5, and we have been seeing our negative sign conversion is given here. That's why it will be downward, so it will be 0. Okay. So this component has ended. Now we'll calculate C, D, E, this component. So we'll taking this moment before going to the here. So as we know the same, as we know this is the same, this is the same point. That's why we will taking this moment continuously at the same zone. Okay, let's see. So we're transferring the moment, but it will be opposite. It will taking anti-clockwise, but it will be clockwise. And 2.5 would also will be taking from balance purposes. Okay, so let's see. Here's 30.33 is given upward, and 3 into we know the distance is given 8 into 4, which is 12, and it will be upward also 2.57. So after the calculation, we've been taking the shear force taking upward, and then it will be a downward, which is 3 into 6. As we know the distance is given here 8, and this is by 4. So this will be 8 and this will be 4. So 3 into 8, and it will be go downward, and it will be 13.3 will be upward, it will be 12, and we know 3 into 4, it will be 12, so it will be 0. We've been found the positive as a positive. Now we'll calculate the distance of x from shear force. We will know 2.54 is given here, and distance x, and 21.43 and 8 minus x, and found the x value is 3.86. After the founding with this value, and now we're calculating the moment is here. We've been known moment is given here 51.5 unit upward, and then we've been calculating this value, and positive it is going downward and this downward after calculation this area. Okay, now we can see another the shear force bending moment diagram. The following began. We can see this is our main diagram. We can see first we have been taking this part. We have been taking here as part kit is given downward, so back kit is given downward, and for balance purpose we have been taking the upward is 5 watt, and the moment will be 10 kip. So we are taking 5 is we are taking the 5 in upward. This is the 5. As this is the left side, we will calculating. We will drawing a diagram. All the diagram will be starting the left side, not right side. That's why it is going the upward 5, and there is no put, and there is going to the downward is applied force. So we've been seeing here there is no load. So if we calculate it here, we know 10 into 5 into 10, which is downward, which is minus 10. So now we're calculating here. As we know, this is our this zone is the moment is 10 kip. So we are transferring this moment. This moment is transferring here. After transferring here, I'm just erasing here. The moment this free body diagram will be like this. Now we're calculating here. We've been seeing here shear force. There is no shear force. Yes, there is no upward load. There will be shear force will be 0. On the other hand, we've been seeing here the 10 kip load is we've been found the anti-clockwise. This is the anti-clockwise. That's why it is going downward. And after we have been found upward is 10 shear force. That's why it will be 0. So this here completed. Another load we have been seeing a shear force diagram from the following figure below. The load is given like this. So now at first we're calculating this parameter. We'll calculate. So we're taking here. So after calculating, at first we've been calculating here 10 kb is given here. The slope is given. So it will be x direction 10 into 3 4 into 5 4 into 5, and y direction it will be vertically it will be 10 into 3 by 5. It will be like this load. 6 kip load is downward, and 8 kip load is left side. So this load is applied to here, as we know, applied to all this load is applied. We have to apply to all this here. Uh, so first of all, we have to calculate. I think we have to calculate. Um, I think we have to calculate this portion, not this portion. So I'm just erasing here. As we have been getting all this value, all the value have been found. So we are taking this here at 6 keep is downward and 8 keep is uh, 8 kb is left side. So the balance purpose we've been taking the 6 kb is upward and 8 kb is here, and we are taking moment here 6 into 8, so it will 48 is acting like this. So now we'll do the shear force, which is going we're always try to we're always starting shear force and bending moment from left side. So that's why we're taking the here the 6 kb is upward, and there is no load, and it will be counter, and the downward is follow. The shear force is here. The bending moment we have been seen here, the 48 is already applied, so that's why 46 is negative, and we have been seen 4 into 8 will be 48, it will be 0 here. So after this founding this diagram, this is the this joint. So we are taking this here all the calculation for balance purposes. So after we've been 6 keep 8 keep is downward, so they will use 8 keep here. So we'll starting the left side, that's why 8 keep will be down and it will be no force and it will be upward, is like this. So we've been seeing the clockwise 48, we've been taking the 48 and putting area, this area will be 48, it will be 0. Okay, so let's see another example. It might be last one, so let's see the last example. No, this is not last, there is another example here, this will be last. Okay, so you can see here that the shear force bending moment of the following figure is given below. We can see here. So we're taking the moment in E point, and we'll found the Fy. Here is the Fy, and we'll taking the summation of Fy, and we'll find the Ey, and we'll taking the summation of Fx, and we'll find the Ex. Okay, after this value, founding this value, we are taking the point EB, this diagram. Just we are taking this diagram, as we have been know the load is acting here. So this load is acting here, and for balance purpose we are taking the 3, and 30.2 and 30.2 will be here. We are taking the moment here is 2 into 5, which will be 10 keep in clockwise. So we're taking we're starting shear force diagram for left side, that's why 2 is given a negative direction and going here and going upward, and it will be shear force diagram. And we've been seeing the shear force diagram another, we've been taking here 2 into 5, which is taking the 10, and another is for balance purpose it will be upward and it will be 0. Now another you can see here diagram FC. So this is the FC, we've been seeing here FC. So we've been seeing the load is 16, is axial load 16, and we've been found 2 load is given here, 2 load is given here. So balance purpose we've been taking the upward is 2, so upward 2, and we're taking the moment 2 into 2, it will be 4. So the shear force we're taking the here minus 2 is the shear force in given here, and shear moment is minus 4. Now we are transferring all the moment here, such as this at first I'm taking changing color, not this. Okay, I'm changing this color. So this portion we are transferring here, as we know this portion is this portion, and another portion, another joint is here. So another joint is here. So all the moment and shear we have been transferring here. So after transferring here, we are doing the shear force here. We have been founding here. The value is given. The UDL is 3. So the UDL is 3 into 3 into T, it will be 6. So 3 into T, it will be 6, and shear force 13 will be upward, and it will be 7.2, and going to the downward it will be 7.48, and it will be upward for 16.8, and it will be 9, and then it will be shear force will be 0. Now we'll calculate the x distance. How we'll calculate this x? After calculating here 7.2 into x into 7.8 into 5 minus x, and it will be 2.8, so it will be 2.8. So after this folding diagram, and we'll calculate the shear bending moment diagram from this diagram. So let's see the last diagram. We can see here the shear force and bending moment diagram, the following figure given below. So the diagram is given here. So we're calculating in upward 5 into 4 into 5, and found this 4 in downward, and left side into 5 into 3 into 5 is 3. So there is a internal is given here. So moment we have been taking the moment is F, and found gy is 7.4, and summation of f of y, and found 17.5. Now we are calculating this portion, which is f, c, and a. This is this portion we are calculating here. So after calculation here, we are calculating all these below summation of f of y, and found cy, which is 5.5, which is 5.5, and summation of f of x, we are taking the moment here, and cz, cx will be 2.2 in left side. This is the left side, and summation of f of x will be between 2.2. It will be f of x here. So after taking here, we are taking the we are drawing the free body diagram here. Is 2.2 is 2.2, and 17.7 17.7. So it is 2.2 is downward, and it will be upward for balance purposes. So shear force is taking the 2.2 is downward, and there is no load, and it will go in the upward, and it will be 0, and the shear force will be 0. So now we're taking the bending moment diagram. How draw? As we have been seen here, 2.2 is downward, and the distance is given 5. So 5 into 2.2, it will be 11, and our for the balance purposes we have been found 11. So it will be upward. Ultimately, bending moment will be 0. And we have been taking another from this section to this section. How we're taking this only this section. Up to the what I will say up to the internal hinge. So we've been taking the 17.5. This is the 17.5 we've been taking here. For balance purposes, it is taken the upward, as it is given the downward. And the balance purposes, we have been found 11, which is the bending moment, and it was the clockwise. That's why it is act in anti-clockwise. Okay, so let's see. So after this finding this below, the shear force has been 3 into the distance is given here, 2 feet and 2 feet. So it will be 2 feet and 2 feet, and 2 into 3 it will be 6, and the upward will be 17.5. It will ultimately reach at the 11.5, and after the calculating here, and it will be 5.5, and it will be acting 5.5 as the internal hinge. It will be must be 0. So the must be 0 in bending moment. So after the taking the calculation, this area it will be here. So bending moment like this. So this half portion is index. So now we'll calculate another half portion. So this half portion. So let's see. I will calculate this half portion. This half portion. Okay. So we've been taking the summation of f of x, which is gx. We've been taking 2.2. So after this founding all the value we've been taking here. So we're taking this portion, which is GD. The GD is acting here 7.5 is 7.5 is here, and 3.8 is here, and 3 is downward. So it will be downward also 0.8 for balance purposes. Now taking the moment here, which is 3.8 into distance into 3 into 5 into 8. 5 and 3.1 into 2, and 13 feet. So now we'll calculating here. We've been seeing that minus 8 is given downward, and this 0 and this 3 is downward, and this 0 and it will be 3.8 is upward. We're starting from left side. So when we're taking here the 13. The shear force diagram we've been taking here, the moment is 13 is given upward, the shear force is the downward. That's why it will be negative minus in calculating all the values here. After here, the balance for balance purpose, this joint will be the joint will be acting like this. The balance purpose we've been carrying all the load is here for sake of the balance purposes. So we've been seeing 5.5 is upward and downward is 3, and it will be acting like 7.5 as we've been seeing here. 7.5 it will be act is like that, and 4 kip is given in the here. So we've been seeing this is the balance purposes. So now we've been seeing the upward is 5.5. 5.5 is gone and upward, and 6 into 3, which will be here, and it will be 3.3, and is going the upward 7.5 in ultimately reaches 4, and going to the here, and the lastly we have been reaching here, it will be 0. After finding this value, we'll just we'll sum up this here, this portion, and drawing the bending moment also. So I have that the lecture is in that. If you have any question, let me know. I will try to give you one answer. Thank you everyone. Thank you all.